Hello, welcome to everyone in this video. Today we want to discuss about Zeeman effect. This is the effect which actually covered in the atomic physics part. If you wants to watch different physics related theoretical part and the solution of different problems asked in different books, you can go through the description box or in this channel there are separate playlist. You can go through this playlist, you will be get the solution of different books like vector analysis by ms Spiegel and etc. And there is different playlist for theoretical part of different physics related concept. So if you want, you can go through the description box or the channel playlist, you will be get different video. Today we want to discuss about the basics and the uh, spectra of the about the Zeeman effect. What do you mean by Zeeman effect? And after that we know about the transverse Zeeman effect, longitudinal Zeeman effect, normal Zeeman effect, anomalous Zeeman effect, Stark effect, Passenbach effect, D1 D2 line splitting. All these things will be covered in this lecture. So let's start. First one is the what do you mean by Zeeman effect? If you want to know about the what do you mean by Zeeman effect, actually Zeeman effect is nothing but the splitting of light in presence of weak or intermediate static magnetic field. That means when a light source, this is a light source, when a light source produces light, it has some frequency, but when we apply a magnetic field within this light source, then the frequency of the light will be changed. This phenomena actually known as Zeeman effect. That means the splitting of light. That means without magnetic field, you will be get a single frequency wavelength light source. That is monochromatic light source. You will be got without any external magnetic field. But when if you apply external weak intermediate static magnetic field, that is the value is less than 1 Tesla, then the monochromatic light converted into polychromatic. That means the frequency of the light will be changed with slight different. So this splitting, that means a single frequency light splitted up more than one splitting, then this is called the Zeeman effect. I think clear. When there is no magnetic field, this source produces a single frequency light, but when we apply the magnetic field, they are produce different frequency magnetic field depending upon the material. Okay, first time 1896 dark species Peter Zeeman observed this effect. That means with the magnetic field there is a shift in the frequency with the help of zinc and cadmium metal. That means you know the source of light depending upon the metal. So they he observed these effects first time in zinc and cadmium metal and obtained the Nobel Prize for it also. Okay, and you know about the fine structure splitting. This Zeeman effect splitting is smaller than the fine structure splitting. Fine structure splitting. Okay. If you want to know the similar effect due to electric field, here we use the magnetic field to get Zeeman effect or the Zeeman effect obtained due to magnetic field. The similar things, if you apply the electric field, this effect known as the Stark effect. Similar things observed in the due to electric field known as the Stark effect. And you use air weak and intermediate magnetic field, but if you apply strong magnetic field, then this effect known as Passenbach effect. So this is all about the Zeeman effect, Stark effect, Passenbach effect. Okay, and the energy level in the fine structure splitted in 2j plus 1 Zeeman level. J is the total angular momentum quantum number. So let's come into details. First one, Zeeman effect have two types depending upon the viewpoint. First one, if this is a source, that means here you produce the light, and if you apply the magnetic field by this Helmholtz coil, this is a coil and this is a coil, this Helmholtz coil produces the here the magnetic field, and this is the very useful because you know with changing the current you can easily control the magnetic field in this region. So this is very useful in the experimental purpose, that is the Helmholtz coil. So use here Helmholtz coil. It is special structure. You can see here this is a hollow. This core is hollow in this region. This is in this region. This core is solid. In this region, this core is hollow, such that you can observe the light in the longitudinal position as well as in the transverse position. Longitudinal means the light passes through parallel to the applied magnetic field, and when light passes the perpendicular, viewpoint is perpendicular to the applied magnetic field. This is transverse. So in longitudinal, the light is parallel to the applied magnetic field. In transverse, light is perpendicular to the magnetic field. So if you view at the transverse position, then this is called transverse Zeeman effect. When you view from longitudinal position, this is called longitudinal Zeeman effect. Okay. Here in this viewpoint, when this viewpoint is perpendicular, that is transverse Zeeman effect, there are the pi and the sigma component. What is pi? When the electric field and the applied magnetic field is parallel. Electric field of the light is parallel to the applied magnetic field, then this is called pi component. When this is perpendicular, that is the electric field of light is perpendicular to the magnetic field or applied magnetic field, then this is called sigma component. So here in this transverse region we will be get pi and sigma component. In the longitudinal position we get circularly polarized component, that is left circularly polarized and the right circularly polarized. Okay. So spectra from the parallel position is longitudinal, and transverse position this is transverse Zeeman effect. Clearly, now comes into the point, that is the normal Zeeman effect and anomalous Zeeman effect. What do you mean by normal Zeeman effect? When the material which used as the source material of light source, uh, if the spin quantum number, that is the spin of this material will be 0, then you will be get the normal Zeeman effect, and if the spin is not 0, then you will be get anomalous Zeeman effect. In normal Zeeman effect, what happens? So you can say that is total spin 0. If there is a single electron, there cannot be total spin 0, so single electron cannot make the normal Zeeman effect. Clear? And if you can see, even number of electron is required, but this is not sufficient condition, because if you have two electron, this is the electron number is even, but this total spin is not 0, this spin is 1. This is the same orientation, so spin is 1. So you can see, you for normal Zeeman effect, the condition is that total spin must be 0. Total electron number must be even, but this condition is not sufficient, not necessary. This condition is necessary but not sufficient. Okay, sufficient condition is that you make two spin is 0 to get normal Zeeman effect. When the spin is not 0, you will be get anomalous Zeeman effect. Why this is called anomalous Zeeman effect? Because when this Zeeman effect actually observed, that time spin is not discovered. That's why this type of electron get the same type of spectra, but this type of atom you will be get the same type of spectra, but this type of atom does not get the same type of spectra. These spectra are not same, this is the different from this one, that's why this is called anomalous Zeeman effect. That time this is taken as anomalous because that time spin is not discovered. After discovering the spin, they explain that is the due to spin. When spin is 0, you will be get the normal Zeeman effect. When the spin is not 0, then you will be get the anomalous Zeeman effect. In the normal Zeeman effect, actually in the perpendicular position, that is the transverse Zeeman effect, will be get three frequency. Number one is the same frequency nu, that is the source without magnetic field, will be get the frequency nu. This frequency will be obtained, which is the pi means is the parallel to the electric field and magnetic field, external magnetic field. And another two, one nu plus delta nu and nu minus delta nu, there is a shift, this is called Zeeman shift. These two both are the sigma component. Sigma means this are the perpendicular. The electric field and magnetic field are the perpendicular. So this all about the normal Zeeman effect, where at the transverse position you will be get three frequency, and at the longitudinal position you will be get the two frequency. One is the left circularly polarized component, another one is the right circularly polarized component. So this is all about the normal Zeeman effect, where this transverse component will be get 3 spectra and the longitudinal component will be get the 2 spectra. But and you remember that that is the intensity of the pi is equal to the intensity of the sigmas. That means total intensity of this one component is equal to the total intensity of these two components. So this is for normal Zeeman effect. In case of anomalous Zeeman effect, this is not the similar things. The longitudinal part is not effectively changed, but the transverse part is effectively changed. That is the typically transverse written here. And the transverse component for normal this is 3, but in anomalous there is various large number of component arises depending upon the material. We will be discussed with the example. Okay. So I think clear about the transverse Zeeman effect, longitudinal Zeeman effect, normal Zeeman effect, and the anomalous Zeeman effect. Now comes into the theoretical explanation why this Zeeman effect arises and which material gives you the normal Zeeman effect, which material gives you the anomalous Zeeman effect. Main thing is that when the spin is 0, this is normal Zeeman effect. When spin is not equal to 0, you will be get the anomalous Zeeman effect. Now comes into the theoretical part. If you take the orbital angular momentum is L. Orbital angular momentum means when this electron precise about the nucleus. This is the nucleus. When this electron precise here, this electron precise means there is a when this electron in along that one, the current is produced in the opposite direction, and this current produced gives you the angular momentum. So this angular moment due to rotation of this electron is the orbital angular moment, that is L, and the spin angular moment, that was spin. If you take these two as a orbital angular moment L and the spin angular momentum S, hence orbital angular moment mu L equals to minus E by 2m L vector. Okay, and spin angular momentum equal to, so in case of L this is L, and in case of spin this is 2 into spin. This is already discussed in the atomic physics. Okay, now the total magnetic moment in the vectorical sum of these two things will be this one. Okay, so for these two magnetic moment you will be get torque equal to mu cross B. So if you just put this value you will get this expression. Now the things, this torque means this is the rotation happening due to this magnetic field. When this magnetic field is produced like that, there is a apply the magnetic field along that direction, and mu is that direction. So this torque precise this uh, magnetic moment. Now in case of weak and intermediate magnetic field, the coupling of L and S, that is the J, that is the summation of L, that is the orbital angular moment, and S means spin angular moment. When these two are combined into J, total angular momentum, which process to the external magnetic field when the magnetic field is weak. But in case of the strong magnetic field, individual N and S can be precise. So you can see here, if there is a L and this is J, sorry, this is S, so you will be get this is J. So this J actually rotate about the magnetic field in case of weak, but in case of the strong, this L precise and this S precise individually. So this is the basic difference when we apply weak and we will apply strong. So Zeeman effect actually observed in weak magnetic field. Now, so for weak magnetic field, you can see this theory says that this L and S does not individually precise. Their combination J will be precise about that. So this mu is written as like that, L plus 2S. So L plus S plus S. This is J. J is the combination of orbital and the spin. So I can see this mu is not parallel to J. This is not parallel to J. There is addition of S. But if you take mu J, which is the component of the mu along the J, mu J is nothing but the component of mu along the parallel to J. There is a negative, so you can say this is parallel with the J. So from this relation, you can say that is the mu J is the component of mu L along J direction and component of mu S along J direction. So in case of mu L, you can write down the E by 2m L mod cos L comma J, and component of mu s, it is 2 into 2m by e by 2m s cos s comma j. This is the angle between L and J, because in case of the component, you know, this cos component arise. In case of that also, this is the mu L, that is e by 2m into L, and this is mu s e by 2m into 2x. Okay, and this cos component due to the component. Now you need to find out these two angle, cos of this angle L comma J, and cos of this angle S comma J. You know this J equals to L plus S, so S can be written as J minus L. If you dot S dot it, so dot product with that thing, will be get S square. This dot gives you J dot J means J square, and J dot L to J dot L, and L dot L square. Okay. Okay, so just rearranging the a square equal to j square plus l square minus 2 j dot l means j 2 jl cos of this angle. So from that you will be get this cos of this angle between l comma j equal to j square plus l square minus s square by 2 jl. Similarly, if you write down this j as a l plus s and l equals to j minus s, so l dot l will gives you like that. So finally you will be get l square equals to this one. So the cos s comma j equal to this one. Clear? So you can write down here, that is, if you common these two things, that e by 2m, you will be get this l cancel out, j square plus l square minus s square, and 2j. Similarly, this s cancel out. This is the magnitude of the spin quantum number. Sorry, spin, not quantum number. Spin. These are cancel out here. So if you take 2j, 1 by 2j as a common, you will get this one. This j square and 2j square is 3j square. This is cancel out 1, and this ln cancel out 1. And this can be written as 2j square plus j square beta. So if you divide, take in common 2j square here, you will get this one. So finally you will get this one, and this take as the gj, where gj equals to 1 plus j square plus a square minus l square by 2j square. If you write down this j square, as you know, in the your quantum number, j square equals to actually root under j equal to root under j into j plus 1 h cross. Okay, this actually small j. Capital J is the total angular momentum. Small j is the total angular momentum quantum number. Momentum quantum number. This is a number, and this is a angular momentum. Clear? I think clear. This is must be small j. Okay, just remember this one, small s, and this is small s. Okay, when you take about the value, you just return as quantum number. What is the importance of this JJ? By directly, this gives you the relative separation of Zeeman's level for the different term. So this is the very important term in case of the splitting. So finally, we will get in terms of the angular momentum quantum number. This will gives you root under j into j plus 1 h cross. Okay. So I think clear, and this is nothing but the mu b Bohr magneton. This is nothing but the mu b Bohr magneton. So finally, you will be get this is the okay. Sorry. Mu, sorry. E h cross by 2m is mu b. Okay, no problem. Now we just take these two things. In case of the in the vectorical form, you will be get in the vectorically form, you can write this mu j vector equals to minus mu gj e by 2m j vector, and similarly mu l can be written as gl into this. When this gl is appears when the s equals to 0. When you put s equals to 0, so j equals to l, because j equal to l plus s is 0 means j equals to l. So if you put j equals to l here, s equals to 0 here, you finally got this thing is 0. So finally you will be get 1. So GL is equals to 1. In case of Gs, when this L equals to 0, you will get 1 plus S into S plus 1, because J equal to L here, because L equal to 0. So you will be get in this relation J equal to S, this is S and this is 0. So this finally will be get 2. Okay. So which already obtained in previous one. So this matches is this formula. Hence the energy is nothing but minus mu J dot B. So this can be written as into this form, and this is nothing but the their cos component, that is Z component, that means the component of J along the magnetic field, and Jz is nothing but Mj H cross. So if you put this one, this E H cross by 2m is nothing but mu B. Mu B is the Bohr magneton, 1.907 10 to the minus 7. Okay. So this is the Bohr magneton. You will be get this energy value. Now the separation is nothing but the delta E. If you write down the E equal to like that, so delta E equal to mu B B delta Mj. If you write the energy transition, for the transition, delta E is nothing but mu B B Gj delta Mj. Okay, this is the transition. When the transition appear, emission, the condition will be like that, energy spectrum. So due to this magnetic field, there is a splitting of energy level happening. So this depend on the delta Mj. In case of the normal Zeeman effect, you know the S equals to 0. S 0 means Gj equal to Gl equals to 1. So Mj becomes Ml. Now this you written as that, so delta equal to mu b b delta Ml. Okay. Now the transition happening with this selection rule. Selection rule says that delta Ml equals to 0 plus minus 1. Delta Ml 0, here you remember delta Ml equals to 0 to 0 also allowed. But in case of delta Mj, if you write down delta Mj, actually this is small j because this is a quantum number. This also small n. Okay. This is 0 plus minus 1. So finally here you remember Mj equal to 0 to Mj equal to 0 is not allowed. Okay, so you remember this thing. In case of ml equal to 0 to ml equal to 0, it is allowed, but in case of the j, this is apply in the anomalous Zeeman effect, then it is not allowed. Okay, remember these things. This is for anomalous Zeeman effect. Anomalous Zeeman effect. Okay. In case of the anomalous Zeeman effect, this transition is not allowed, but in case of normal Zeeman effect, ml equals to 0 to ml equals to 0 is allowed. In case of the normal Zeeman effect, there are transverse normal Zeeman component, that is pi and sigma. For ml, delta ml equals to 0 is responsible for pi component. Delta ml equals to plus minus 1 is responsible for the sigma component. So total 3 component observed in the transverse normal Zeeman effect. In longitudinal normal Zeeman effect, 2 circularly polarized component actually observed. Prominently, you will be obtain this spectra splitting actually happening in the transverse component. In case of the anomalous Zeeman effect, there is several component actually arises depending upon the material. We will be give the example to understand these things. First example, we just taken the normal Zeeman effect. Example of the normal Zeeman effect. Try to understand these things very carefully. Then you will be understand the anomalous Zeeman effect spectrum. Suppose there is a transition from 1F3 to 1D2. This is the notation, you know, the molecular spectra, atomic physics spectra notation, that is in this region, this is called multiplicity, right? 2s plus 1 is nothing but the multiplicity. Multiplicity. 2s plus 1. This is the L value, angular momentum. This is the orbital angular momentum. Orbital angular momentum, and this j is the total angular momentum. It's total angular momentum. Clear? So this in this notation here written as this is multiplicity 1 if is the value of L. You know this value of L is written S equal in case of S means value of L is 0, P that is value of L is 1, D for 2, F for 3. So F for 3 in and transited from F to D. For D this is 2. So the multiplicity 2s plus 1 is 1, so S is 0. Similarly here also 1, 2s plus 1 means S is 0. Here L is 3, for F L is 3. For D L is 2, for D L is 2. So what is the value of J? Here written here J equals to 3 and J equals to 2. In another word you can know J equals to L plus S. So J equals to 3 written here, J equals to 2 written here. So the energy, this actually energy splitting without magnetic field. Without magnetic field, this transition actually happening. With the magnetic field, what transition will be happening? You need to derive, right? So number of energy levels splitting in the Zeeman effect, that is due to magnetic field. This splitting up to 2j plus 1, that is 7 level. For 1f3 is splitted out into 7 level. In case of 1d2, this splitted as 2j plus 1, that is 2 into 2 4 plus 1, that is 5 level. So this single 1f3 level splitted out into 7 levels, single 1d2 level splitted out into 5 levels. Clear up to that point? Now you know that is the energy splitting value is mu v into delta ml. So here you can see this is mj, he has the ml, and what is the value of ml? That is the minus j2 plus j, that is the minus j2 plus j. J is 3, so value will be minus 3 2 plus 3, and this is in the that order. This in case of the 1f3 the value of j is 3, so the splitting energy minus j3 plus j, so minus 3 to plus 2. In case of 1d2 the j value is 2, so this is mj equal to minus 2 to plus 2, so this is 5 and this is 7 level. Now the energy splitting will be like that. For this one, if you take E2 and this ml equals to 1, so this is E2 plus mu v into B. This is the splitting excess energy level. So this is E2 plus mu V, for this is E2 plus 2 mu V, E2 plus 3 mu V. Similarly for this is minus minus. Okay. In case of this one also, if you take this as E1 energy level, this split are the same things, that is E1 plus mu VB, E1 plus 2 mu VB. Similarly this is minus 1. Now the selection rule says that this delta ml equals to 0 and plus minus 1. When if you take delta ml equals to plus 1, that means final minus initial equals to 1. So final is 2 and initial is 1. So final minus initial will be 1. So in these things you will be get these five lines where this delta ml equals to plus 1. And when this is the final minus initial equals to 0, so these 5 lines also gives you delta ml equals to 0. You can see here that is 2 to 2, so final minus initial is 0. In case of final minus initial minus 1, that is 2 and 3, so 3 2 minus of 3, that is minus 1. So these 5 lines also for ml equals to minus 1. Now you need to find out their frequency are the same or different. This is the selection rule. Okay, this selection rule says as this there is 15 lines appears. Whether their frequency, actually we did not see this line, we see the actually frequency, the color of this line. So whether this frequency are same, these are same or not, is or we want to discuss. So in case of plus one, you can see there is separation every time is this separation for plus one. This separation is E2 minus E1 final minus initial. So E2 minus energy spectra, this is high, this is low, so it's 2 minus E1 and this minus mu VB. You can see for every line, you can see for every lines this energy is the same. For this one you can see this E2 minus E1 and that's minus that one equal to minus mu VB. For ml equals to plus 1, these 5 lines gives you the same frequency wavelength. Similarly for that 5 one, you can see for E2 minus E1 you will be get this E2 minus E1 only, and this plus 1 you will be get this E2 minus E1 and 3 minus 2, that is mu B. So you will be get only 3 frequency or 3 wavelength. Okay, so this is the same frequency E2 minus E1 we obtained without the magnetic field. That's why this is nu naught. When we apply this these two things, you will be get minus something and plus something. Okay, so this is energy. If you divided by h, so you will be get the frequency. When this is the parallel, this is the 0, this is pi component, and this two are sigma component. The intensity of pi component is equal to the sum of these two sigma component. That's why this is double to this intensity. So this is the normal Zeeman apex vector. You will be get three component here in the transverse view. You will be get three component here. That means you will be get the three frequency light spectra when we apply this magnetic field. When we did not apply this magnetic field, you will be get only nu zero frequency at this. So without magnetic field, we will get in the, with magnetic field. This is for with magnetic field. With magnetic field, we will be get this spectra line. Clear? I think clear. If there is any doubt, you must comment in the comment box. Now comes into the example of the anomalous Zeeman effect. Take this example of sodium light. In case of sodium light, you will be get this P and S and split into two parts. This is for fine structure. Fine structure. This is for fine structure. In fine structure, this P is converted into 2P 3 by 2 and 2P half. This is the value of J, this is the L, and this is the multiplicity. So there is two lights actually obtained in the fine structure, D1 line and D2 line. D1 whose frequency is wavelength is 589696 Armstrong, and D2 is the 5890 Armstrong. This frequency is low, so wavelength is high, and this frequency is high, so wavelength is low. Now we will be discuss when this is without magnetic field. If you apply the magnetic field, how many spectra actually arises of D1 line and D2 line? Without magnetic field, we will be get only two spectra. Okay, we will be get only two spectral lines, D1 line and D2 line. But when we apply magnetic field, then how many numbers of lines actually appears of D1 line and D2 line, you need to know. Clear? For D1 line, we just talking about, we want to first talking about D1 line. Okay, so D1 line transition is happening to P half to 2S half. Clear? Here you can see 2 is written here. So this multiplicity for here you can see multiplicity is 2s plus 1 equals to 2, so that is s equals to 1 by 2. I think I write correctly, is equals to half. So a spin is not equal to 0, so this is not a normal Zeeman effect, this is anomalous Zeeman effect. Similarly here 2s plus 1 is equal to 2, so a is equals to half also. P means L equals to 1, S means L equals to 0. And J is written here half, half. So 2J plus 1, if you write here 2J plus 1, that is 2 half. So this is 2. And here also 2J plus 1 equals to 2. So there is splitting of energy level will be 2 and 2. Now what is the value of G? You know, here you need to taken about the value of G, which is converted into ml, delta ml, but here you need to know about the, because in case of mu j, this, in case of normal Zeeman effect, this mu j value is 1, so there is no problem. But in case of anomalous Zeeman effect, this mu j is cannot be 1, so you need to find out the G value in these two cases. For this one, for 2p half, what is the value of G? So G is formula is 1 plus J into J plus 1, actually this is small, J into J plus 1 plus S into S plus 1 minus L into L plus 1 divided by 2J into J plus 1. This is the formula. If you just put this value of here, 1 plus J is half, so half into half plus 1, S is half, half into half plus 1, and L is 1. So 1 into 1 plus 1, and 2 half into half plus 1. So finally if you just multiply it with 4 here, so you will get 1, and this is 3 plus 1 3, minus if you multiply it 4 here, you will be get 4, 4 into 2, and this is multiplied with 4, this 2 cancel out with 4, so this 2 is cancel out, so finally you will be get 2 into 3. So if you calculate these things, you will be get that is 336, and this is 8, that is minus 2, 6, that is 1 minus 1 by 3, that is 2 by 3. So in case of this energy level, the value of G is 2/3. For S 2/2, for this level, what is the value of G? You can see this value S is half, L is 0, J is half. So what is the value of G? G is 1 plus J into J plus 1, J into J plus 1, plus S into S plus 1, minus L into L plus 1, divided by 2, J into J plus 1. This is small j. So finally you will be get 1 plus half into half plus 1, half into half plus 1, L is 0, divided by 2, half into half plus 1. So this is nothing but if you divide multiply with 4, that is 1 into 3, 4, so 2 into 3, this is 2 into 3, this is multiplied here, this is also 2 into 3. Clear? So you will be get these things here, 1, 2 into, sorry, 2 to cancel out, 4 into 2, 4 into 2/3, that is 2 into 3. Here 4 cancel out, this is 1 into 3, this is 1 into 3, so this gives you 1, so finally you will be get 2. So we got the value of G in these two lines. Clear? So if you want to write down the energy spectra, delta E is nothing but mu b into mu b into gmj. This is the spectra energy splitting. So there is two splitting here, for this one two splitting and this one also two splitting. That means if you take, that is 2p half, 2p half, and this is 2s half. Clear? So this splitted up into two component. Similarly this splitted up into two component. Number one is this is the value of E2. If you write down, this is the value of E2, and this is the energy value of E1. But this delta mj for this one equals to minus j to plus j, that is minus half to plus half. So if you write down the value of mj, this is plus half, this is minus half. Similar for that one, this is plus half, this is minus half. So what is the value of G into mj? What is the value of G into mj? This is the value G into mj. G for that one, for P, the G value is 2/3. If you multiply 2/3 into half, if you multiply 2/3 into half, you will be get 1/3, and similarly minus 1/3. And this is for also the value of G equal to 2. So G into mj, this is 1 and this is minus 1. Clear? So what is the value of delta Eg? This is E2 plus mu b into G into mj, which is 1/3. So 1/3 mu b. Similar for that one, E2 minus 1/3 mu b, and this one, this is E1 plus mu b, and this is E2, sorry, E1 minus mu b, G into mj. So you will be get the energy level. Then your condition is that delta mj equals to plus minus, sorry, 0 and plus minus 1. This is the selection rule. If you take delta mj equal to plus 1, we just take this plus 1, then 0, then minus 1. If you take delta mj equals to plus 1, delta mj equals to plus 1, if you take this one, what happened? Plus 1 means final minus initial is 1. Final minus initial is 1. Final minus initial is 1. Right? Final minus initial is 1. So final minus initial is 1 is this line. So this is for delta mj equals to plus 1. Final minus initial is 1. So for that, what is the energy value? E2 minus 1/3 mu b minus u1 plus mu bb. So this is E2 minus E1 minus 1/3 minus 1, that is minus 4/3, minus 1/3 minus 1, that is minus 4/3. This is the value, and there is no other component can arise delta mg equal to 1. But if you take this delta mj equals to 0, that is final minus initial is 1, so delta ml equals to 0, so final answer will be 1. So this is half to half transition 0, and this is minus up to plus 1. So we take that this is 1 and this is 2. Write down this is 1 and this is 2 taken as, right? So in case of 1, so what is the energy gap? Energy gap is E2. Whether their frequency is same or not, you need to find out. The transition selection rule gives you these two spectra. So whether these spectra frequencies are same or not, you need to find out. So just difference to these energy levels, that is E2 plus 1/3 mu b minus U1 plus mu bb. So what is the value? E2 minus E1, E2 minus E1, and this is 1/3 mu bb minus mu bb, that is minus 2/3 mu b. Clear? And number 2, that is E2 minus 1/3 mu bb minus E1 minus mu b. So this gives you E2 minus E1. This is plus, so plus mu bb minus 1/3. So this is plus 2/3 mu bb. So we can see this energy and this energy are different, so their frequency also different. So these two gives you actually two spectra. These two gives you actually two spectra. And delta mj equals to minus 1. When this delta mj equals to minus 1. When this delta mj equal to minus 1, if you get that is the final minus initial equals to minus 1. This minus of this one. Final minus initial gives you 1. So this is the, okay, take different color. Sorry. Final minus initial is give you. So this is delta mj equals to minus 1, and this was the this is for delta mj equals to 0. Clear? So in case of delta mg equals to minus 1, what will be the value? Energy value, energy gap will be E2 plus 1/3 mu bb minus U1 minus mu bb. So this gives you E2 minus U1, and this is plus, so this is 4/3 mu bb. So finally you will be get 4 spectra. There are frequency are different 4. So these two, these 4 you will be finally get 4 splitting. Clear? In case of the normal Zeeman effect, you will be get 3 splitting. But here you can see this transition, that is D1 transition, gives you the 4 splitting. 4 number of splitting actually gives this wavelength. Okay, in fine structure you will be get these 2 wavelength, but in the Zeeman effect this one frequency splitted into 4 component. Okay, and delta mj equals to 0 gives you pi component, and this gives you sigma, and this gives you sigma. So there are 2 pi component and 2 sigma component. There are 2 pi component and 2 sigma component. So if you want to write down this pi component and sigma component, just here you can see this 2 pi component and 2 sigma component. So the write down here also like that. If you take these two as sigma component and these two are pi component, and the frequency of this pi component are not the same as if you take this as nu naught, and you can see this is this gives you nu naught. So nu naught minus this one, so this value of at this position frequency will be nu naught plus 2/3 mu b by h, and the value of this region will be nu naught minus 2/3 mu b by h, and this is pi component, this is also pi component, this is also sigma component, this is also sigma component. And for sigma component you can see here this is plus and this is minus, so this is 4/3. So the frequency at point is 4/3 mu b by h, and for that nu naught minus 4/3 mu b by h. So this is the frequency's value, and so this is the intensity of this one, and this frequency nu naught frequency gives you the d1 line. I think clear about the splitting of d1 line into 4 component. 2 is the pi component, 2 is the sigma component, and their frequency will be like that. If you take this as the frequency of d1 line, the 4 components frequency will be like that. Clear? I think clear. If there is any doubt, you must comment in the comment box. Now comes into the point of d2 line spectra. D2 line spectra. Okay, d2 line. D2 means the transition from 2p3 to 2s half. D2 means 2p3 to 3 by 2 to 2 actually here 2s half. So for 2p 3 by 2 you can say 2s plus 1 is 2, that is s equals to half, and p means l equals to 1 and j is written as 3 by 2. So 2j plus 1 equals to 2 into 3 by 2 plus 1, that is 4. So number of splitting of this single energy levels into 4 components. And what is the value of g? G is 1 plus j into j plus 1, that is 3 by 2 into 5 by 2 plus s into s plus 1 half into 3 by 2 minus l into l plus 1 by 2 into j plus 1, 3 by 2 into 5 by 2. If you multiply by 4 into this is 15, this is 3, 8, and this is multiplied with 4, you will get 10, 30. So you will be get 1 plus this is 5, 20 by 30 minus 5, 10 by 30. So 1 plus 1/3, that is 4/3. Clear? And for this state, this value 2s plus 1 is 2, so s equals to half. Since s is not equal to 0 here, it is also anomalous Zeeman effect. L equals to 0 here and j equals to half here. Clear? So what is the value of 2j plus 1? That is 2 into half plus 1, that is 2 splitting. Number of splitting is 2. Here the number of splitting is 4. Now what is the value of g? G is 1 plus j into j plus 1. J is half into 3 by 2 plus s into s plus 1 minus l into l, this is 0, by 2 into j. J is half into 3 by 2. So you can see this is same thing. So the value of g equals to 2. Clear? I think clear. This is the same thing. So 2 into this. So 1 plus 1, that is 2. Clear? Now what is the value of j into j plus 1? So clearly visualize this thing. So splitting of light. So this is splitted. This is 2p 3 by 2. This is splitted into 4 component. This is splitted into 4 component. 1, 2, 3, 4. And another, that is 2s half, that is splitted into 2 component. So what is the value of mj? This is mj is minus j to plus j, that is minus 3 by 2 minus 3 by 2 minus half plus 3 by 2. Similarly, this is j equals to half, so minus half, and this is plus half. So what is the value of g into mj? Here the g value is 4 third. If you multiply 4 third into 3 by 2, 4 third into 3 by 2, that is 2. So this is 2. And if you multiply 4 third into half, that is 2 third. And this is the minus 2 third, minus 2. Similarly, half and this is 2, you will be get 1, and this is minus 1. What is the value of energy? This energy is E2. This middle energy also E1. So what is the value? Here the E2 plus 2 third mu BB. This is E2 plus 2 mu BB. This is E2 minus 2 third mu BB. And this is E2 minus 2 mu BB. Similarly, this is E1 plus mu BB, and this is E1 minus mu BB. So condition 1, first condition, delta mj equals to plus 1, that is final minus initial will be plus 1, final minus initial will be plus 1. So this minus this plus up minus up will gives you the this minus up and plus up will gives you the delta mj equal to 1, and another one minus up and is 3 by 2. This also gives you the delta mg equal to 1. For one you will be give the energy difference. You need to these two are comes from delta mj equals to plus 1. Whether their frequency are same or not, you need to find out. So if you take this energy difference, that is E2, this E2 minus E1, that is E2 minus 2 third mu BB minus E1 plus mu BB. What is the value? That is E2 minus E1 minus 2 third minus 1, that is minus 5 by 3, minus 5 by 3, 5 by 3 mu B. And number 2, for number 2 transition, that is E2 minus 2 mu BB minus E1 minus mu BB. So you will be get this E2 minus E1 and minus 2 plus 1, minus 2 plus 1, that is the minus mu BB. So these are the defined. So these two are defined to spectra. Next one, when the delta mj equals to 0. 0 means half and half, half to half transition, and minus half to minus half transition. These two are delta mj equals to 0. Taken this as 1 and this as 2. For one, for one, the energy gap is E2 plus 2 third mu B and minus number 1, that is E1 plus mu BB. What is the difference? E2 minus E1, and this 2 third minus 1, that is minus 1 third. 2 third minus 1, that is minus 1 third mu BB. And in case of second line, you get this difference E2 minus 2 third mu b minus u1 minus mu b. So this gives you e2 minus u1 minus 2/3 plus mu b, so plus 1/3 mu b. So then these two also again difference, so you will get the different spectra. Number 3 condition, delta mj equals to -1. So -1 gives you 3/2 to half, 3/2 to half, and half to -1. You will be get delta mj equals to -1. Final minus initial -1, final minus initial -1. Okay. There are also two components, 1 and 2. For 1, this value is e2 plus 2 mu bb minus u1 plus mu bb. So you will be get e2 minus u1, 2 mu bb minus, so this is mu bb. In case of 2, this is e2 plus 2/3 mu bb minus u1 minus mu bb. So what will be the value? That is e2 minus e1, 2/3 plus 1, 2/3 plus 1, that is 5/3 mu bb. So these also are different. So you can see these 6 energy levels are different. These 6 energy levels are different. So finally you will be get 6 spectra, 6 splitting. So this line actually gives you 6 splitting, 6 different lines of spectra. If you write down this in the frequency scale, if you write down this in the frequency scale, what will be the value? Suppose this is mu naught. Now you can see here for delta mg equals to 0, that is pi component, there is, this is mu naught minus 1/3 mu bb and plus 1/3 mu bb. So these two pi component, the frequency will be mu naught plus 1/3 mu bb by h in the frequency term, and this is mu naught minus 1/3 mu bb by h. This is pi component, this is also pi component, because delta mg equals to 0. In case of delta mg equals to plus 1, there are two mu naught minus mu bb and plus mu bb. Mu naught minus mu bb, and there are also mu naught plus mu bb. These two are sigma component, and another one is the minus 5/3 mu bb plus 5/3 mu bb. Another two component also arises here like that. Mu naught minus 5/3 mu bb by h, and this is mu naught plus 5/3 mu bb by h. This also sigma component, For sigma component, intensity must be similar to the 2 pi component intensity. The addition of these 2 pi component intensity must be equal to the addition of the 4 sigma component intensity, and this is the for D2 line. So there are 6 component, 6 splitting actually arise in D2 line, and in D1 line there are 4 component actually arise. I think clear how to find out this splitting. If there is any doubt, it must comment in the comment box. I have a homework for you. Just do yourself this homework and send me the line spectra. How many spectral lines appear in Zeeman effect, Zeeman splitting of the 2D 3/2 to 2P half transition of sodium? Explain. 5 marks question. Okay, you just try to solve. I think you can do this if you clearly understand the previous one, and the answer will be 6. Okay, so verify with your answer and send me the line spectrum. I think line spectrum means this one and this one. This spectra you need to send me in the WhatsApp number or Telegram. Okay, so I think clear. If there is any doubt, you must comment in the comment box. We'll be meet in the next video as soon as possible. This is all about me. This is my contact detail. You can connect me with this Telegram channel. This is my online platform. And this is my YouTube channel details. Go to this channel. You will get different physics related videos, some mathematics. Like this session. If you learn something from this session, share this video to your friends so that he or she also get benefit from this video. Subscribe this channel if you new in this channel. Those already subscribed, thanks for subscription. Press the bell icon to get notification of upcoming videos. So take care. We'll meet in the next video as soon as possible. Thank you.